Good morning. Today we're going to solve the problem 3 of AP Statistics 2022. Let's read the context and see if we can find any key information. It tells us that a machine at the company is programmed to fill shampoo bottles such that the amount of shampoo in each bottle is normally distributed. What is normally distributed? It means that it follows normal distribution. That is related to two factors. The first one is the mean mu, and then the variance sigma square. Okay, so the mean here is mu equals to 0.6 and standard deviation is sigma equals to 0.04. Let the random variable A represent the amount of shampoo in liters that is inserted into the bottle by filling the machine. So it's considered to be underfilled if it has less than half liter of shampoo. So the question is determine the probability that randomly selected bottle of shampoo will be underfilled. So the formula is what? First, we need to standardize the values. Right? So we can convert A equals to a half to a z-score using the formula z equals to x minus u over sigma. It equals to a half minus 0.6 over 0.04. So the result is minus 2.5. Then we need to find probability. So we need the probability of A is smaller than the half. It equals to the probability of Z is smaller than 2.5. So we can look up at the table and see the value is 0.0062. So the probability is 0.62%. That's the end of problem 3A. Okay? Understand? And then we can come to part B. First, we also need to read the context and find key information. The context is that bottles are placed in a box of 10, and the crate contains several boxes. And the one box is randomly selected from the crate. And if two or more bottles in the selected box are underfilled, the entire crate is rejected. So our objective is to define the random variable of interest for the warehouse manager and the state is distribution. So the first step is to define the random variable. We let y be the number of underfilled bottles in the randomly selected box of 10 bottles. Then we can determine the distribution. As we have derived in question A, each bottle has a probability of 0.62% of being underfilled. The bottles are independent as given in the problem. So the number of underfilled bottles in a fixed number of independent trials, which is 10 bottles, with the same probability of success, it follows a binomial distribution. Therefore, y follows the binomial distribution, that is n equals to 10 and P equals to 0.0062. That's for the question 1. And question 2, the probability that a crate will be rejected. So the given information is that from part A, the probability that a single bottles enter field is 0.062, and it follows a binomial distribution. So our objective is to find the probability that the crate is rejected. That is, P y is greater than or equal to 2. So the first step is to derive the expression of P y greater or equal to 2. So it's equals to E minus the probability of y equals to 0 minus the probability of y equals to 1. And then we calculate P y equals to 0. Since it follows the binomial distribution, so equals to E 1 minus P to N equals to 1 minus 0.0062 to 10. So the final result is 0.9397. And we can express in the percent form. Then we calculate y equals to 1. So the final result is 0.0586. Right? Then we can minus them. So it equals to 0.0017, which is 0.17%. So this is the final answer of the second question. Do we have any problem? So we finally come to part C. Our aim is to reduce the number of crates rejected. So the company consider adjusting the programming of the filling machine so that the amount of shampoo in each bottle is normally distributed with mean 0.56 liter and standard deviation of 0.03 liter. So only the two parameters, that is the mu and SD, adjusted. So the only thing we need to do is to modify the data, but we can apply the same technique utilized in problem A and B to do it again, right? So the first step is still calculate the probability. The mu z equals to 0.5 minus 0.56 over 0.03. So the new z value is minus 2. So we need to find P A is smaller than 0.5. It equals to z smaller than minus 2. So the value can be looked up from table. It is 0.0228. And this is the first step. The next step is to calculate the rejection probability. It still follows the binomial distribution, only with the value of P changed. So we apply the same technique. That is, the probability of y larger than or equals to 2 equals to 1 minus probability of 0 minus probability of 1. So the probability of 0 can be computed as 1 minus p to 10, and the probability of 1 equals to the combination of 10, 1 multiplies the probability multiplies 1 minus the probability to 9. So the final value is 1 minus 0.792 minus 0.185. The final result is 0.023. So the third step is to compare the crate rejection probabilities. In the original one, we can look up from problem B, the probability is 0.17. However, in the adjusted model, the rejection rate is 2.3%. So use the statistical justification. The original one is more appropriate, right? Because it was a lower crate rejection probability. So the last step is because 0.717% is smaller than 2.3%. So we apply the original programming. Okay. So that's the end of the whole question. If you have any questions, please feel free to ask. Thank you.